Did you know that right now, somewhere on a noisy highway, parked beside a rumbling truck stop, or wedged next to a neighbor who thinks 11 p.m. is a great time to run a leaf blower, there's a tiny house sitting in near-perfect silence? No thick concrete walls, no basement, no suburban lot buffer, just a well-built tiny home with a secret baked right into its bones. That secret is a built-in sound barrier system, and today we're going to break it down completely. What it is, how it works, exactly what it costs, and whether you can actually build or buy one in 2026 without wrecking your budget. And here is the thing most tiny house channels will never tell you. The worst enemy of comfortable tiny house living is not the size. It is the noise. Stay with me until the end, because I'm going to show you the one assembly method that most tiny house builders still get completely wrong, and it is costing people their sleep and their sanity. If you're new here, welcome to Affordable Tiny Homes, where we give you honest, research-backed information on alternative housing that actually works for real people and real budgets. Hit subscribe and tap that bell so you never miss a build breakdown. Let us start with the problem that almost nobody talks about in tiny house marketing videos. Tiny homes are loud, not because the people in them are loud, but because of how they are built. Here is the physics. Standard tiny houses on wheels, what the industry calls THOWs, are built with lightweight materials by necessity. Most states require a THOW to stay under 13,500 pounds gross vehicle weight to be legally towable. That weight limit forces builders to use thin plywood sheathing, vinyl siding, and lightweight interior finishes instead of the heavy construction materials that naturally block sound in a traditional stick-built home. The result? A standard tiny house wall assembly, which is typically just a 2x3 or 2x4 stud bay with a thin layer of fiberglass insulation and a single sheet of drywall, achieves what acousticians call an STC rating of around 33 to 36. STC stands for Sound Transmission Class. It is the industry standard number that tells you how many decibels of airborne sound a wall will block. And here is what STC 33 actually means in plain language. At that rating, normal conversation on the other side of your wall is clearly audible. You can hear almost everything. That is essentially the same noise isolation you get from a standard interior apartment wall with no insulation at all. Now think about the environments tiny house people actually live in. RV parks with generators running at 6 a.m. Urban infill lots next to traffic. Community land where your neighbor's music thumps through thin walls. Or even just the refrigerator compressor and the HVAC unit cycling on and off 2 feet from your sleeping loft. The problem is not just external noise. Inside a tiny house, every room is essentially the same room. Your kitchen is your bedroom and your living room. In a space that might be 200 to 300 square feet, sound travels everywhere instantly. But here's what builders are now doing differently. And this is where it gets genuinely interesting. A built-in sound barrier is not a single product. It is not a foam panel you slap on a wall after the fact. It is a layered wall, floor, and ceiling assembly that is engineered from the framing stage to achieve a target STC rating before any interior finishes go in. Professional acoustic designers talk about 4 core principles: mass, damping, decoupling, and absorption. A truly effective tiny house sound barrier system addresses all 4 simultaneously. Let me walk you through each one and what it looks like in an actual tiny house build. Mass. Sound waves are mechanical energy. They lose power when they have to push through heavy material. This is why a concrete wall is quiet and a plywood wall is not. In a tiny house, you cannot use concrete, so builders achieve mass through strategic layering. The most effective lightweight mass material available right now is mass-loaded vinyl, or MLV. This is a dense, flexible vinyl sheet infused with calcium carbonate, a non-toxic mineral filler, to make it extraordinarily heavy for its thickness. A standard 1 pound per square foot MLV sheet is just 1/8 of an inch thick. That is barely the width of 2 pennies stacked together. But that thin sheet weighs a full pound for every square foot of coverage. When you staple or screw MLV directly to your wall studs before hanging drywall, you are adding a continuous heavy membrane that forces sound waves to burn off energy trying to push through it. According to current acoustic testing data, a single layer of 1-pound MLV added to a standard stud wall assembly can push the STC rating up by 8 to 10 points on its own. Pricing in 2026 for standard 1-pound MLV runs approximately $2 to $3 per square foot from major suppliers, with premium grades or adhesive back variants going higher. A standard 100 square foot roll, which is enough to cover most of one wall section in a typical tiny house, runs between $230 and $295 at current market prices. Damping. Damping converts sound energy into heat energy, essentially dissipating the vibration before it can radiate out the other side of the wall. The go-to damping compound in residential builds right now is green glue noise-proofing compound. You apply it between 2 layers of drywall, and as the wall flexes under sound pressure, the compound converts that mechanical energy to heat. It is particularly effective in the low to mid frequency range, meaning it helps tame the bass frequencies and appliance hum that MLV alone struggles with. One thing to know before you build: green glue does not reach its full sound isolating performance the moment it goes in. It takes up to 30 days to fully cure as it dries out and reaches maximum effectiveness. If you move in early and the walls do not feel dramatically quieter on day 2, that is normal. Give it the full curing window before you judge the results. In a tiny house, the most effective damping assembly for interior walls goes like this: mineral wool insulation in the stud cavity, a layer of MLV over the studs, then a first layer of 5/8" drywall, then green glue compound applied to the back of a second layer of drywall, and finally the finished drywall layer. This is often called a damping sandwich, and it is one of the most powerful assemblies you can build without exotic materials. Decoupling. This is the step most tiny house builders completely skip, and it is the one that makes the biggest difference. Decoupling breaks the physical connection between your wall surfaces and your framing structure. Here is why that matters. Even if you pile on mass and damping, if your drywall is screwed directly into your studs, sound vibrations travel through those screws like a telegraph wire. The sound hops right over all your insulation and goes straight through the framing into the next room or the outdoors. The solution is resilient sound isolation clips, often called RSIC clips, paired with a hat channel track. You mount the clips to the studs, attach horizontal metal hat channels to those clips, and then hang your drywall from the channel. The clips have a rubber bushing that interrupts the vibration path. Sound hits the drywall, tries to travel through the screws to the framing, and instead hits that rubber isolator and loses most of its energy. This single upgrade alone, adding resilient channel or isolation clips to an otherwise standard wall, can raise the STC rating by 5 to 10 additional points. And when combined with mass and damping layers, you start hitting STC ratings in the mid-50s, which is the International Building Code minimum for walls between dwelling units in multifamily housing. That is apartment building-grade acoustic performance in a tiny house on wheels. Absorption. The fourth pillar is absorption, which handles sound within the space rather than blocking it from entering. In a tiny house with hard surfaces everywhere, sound bounces and echoes inside the space itself, making everything feel louder and more intrusive. The fix is mineral wool insulation in every wall cavity, combined with soft furnishings, area rugs, and acoustic panels on interior surfaces. Mineral wool, often sold under brand names like Roxel Safe and Sound or Rockwool, is the top choice for cavity insulation in sound-focused builds. Unlike fiberglass bats, mineral wool has a denser fiber structure that absorbs mid- and high-frequency sound waves far more effectively. Current 2026 pricing puts mineral wool bats at roughly $1.10 to $1.40 per square foot, compared to about $0.70 to $0.90 per square foot for fiberglass. The 30 to 40% price premium is worth it in a sound-focused build. One important caveat from acoustic engineers: spray foam insulation, while excellent for thermal performance, provides very little acoustic benefit. When spray foam cures into a rigid mass, it fills the cavity completely and transmits vibration rather than absorbing it. If sound isolation is your goal, Avoid spray foam in interior partition walls and stick with mineral wool or dense packed cellulose. Walls get most of the attention, but in a tiny house, the floor and ceiling are equally critical. If your tiny house is on a trailer, road noise, tire rumble, and vibration come up through the trailer frame, through your subfloor, and directly into the living space. The acoustic fix starts underneath. Sound-conscious tiny house builders are now installing MLV or closed cell foam directly on the underside of the trailer deck before the subfloor goes down. This is sometimes called the trailer belly treatment. Adding a layer of 1 pound MLV to the trailer belly, combined with wheel well liners made of acoustic foam or MLV, can noticeably reduce road noise when towing and wind park noise when stationary. For the interior floor, an impact barrier underlayment installed between the subfloor and the finished flooring addresses what acousticians call impact noise. That is the thud of footsteps, the clatter of dropped objects, anything that creates vibration by striking the floor surface directly. Products like rubber-based impact barrier underlayment, which runs about 0.80 to 1.50 per square foot, are thin enough for tiny house height constraints while still adding meaningful isolation. For the ceiling, which in most tiny houses is right below a sleeping loft, the same MLV and damping principles apply. Adding MLV to the ceiling joist before installing the ceiling finish, combined with mineral wool in the joist bay, can cut loft to main floor sound transfer significantly. If you have a loft bed directly over a kitchen or bathroom, this ceiling assembly is not optional. It is the difference between sleeping and not sleeping. Bathroom plumbing deserves special mention here. Toilets, drains, and supply pipes are some of the noisiest elements in a tiny house. The sound of water draining at 11 p.m. travels through the whole structure. The fix is acoustic pipe wrap, essentially MLV or closed cell foam bonded tape wrapped around every visible drain pipe and penetration, plus closed cell foam sealed around every pipe that passes through a wall or floor. Products like Quiet Wrap Pipe Insulation handle this at roughly a few dollars per linear foot. Here is a truth that acoustic engineers repeat constantly. A wall with an STC rating of 55 is useless if the window in that wall is STC 25. Sound finds a weak point and pours through it. In a tiny house, windows and exterior doors are typically the worst acoustic performers in the entire assembly. A single-pane window might have an STC of 18 to 20. A standard hollow-core interior door might be STC 20 to 25. Both are essentially acoustic holes in your wall. The upgrade path for windows is double-pane insulated glass units. A quality double-pane window with an air or argon gas gap between panes typically achieves STC 28 to 32, which is still not impressive in absolute terms, but is a significant improvement over single pane. Laminated glass, which sandwiches a polymer interlayer between glass panes, can push window STC ratings into the 35 to 40 range and is becoming more common in high-end tiny house builds. For exterior doors, a solid core door is the minimum for sound performance. Solid core doors with proper compression weather stripping on all four sides can reach STC 30 to 35. The weather stripping seal matters as much as the door itself. A solid door with gaps at the frame leaks sound the same way it leaks air. One more trick builders use: acoustic caulk around every window frame, electrical outlet, and switch plate. Every penetration through a wall is a flanking path for sound. Sealing those penetrations with acoustic caulk, not standard construction caulk, closes the flanking paths that undermine everything else you have built. Let's put real numbers on this. A standard tiny house build uses fiberglass bat insulation, standard drywall screwed directly to studs, and basic windows. That is the cheapest approach, and it gives you STC ratings in the low 30s. Comfortable for some situations, miserable if you park near noise. A mid-range acoustic upgrade, adding mineral wool insulation, a single layer of MLV on all exterior walls and the floor belly, and sealing all penetrations with acoustic caulk adds roughly $1,500 to $3,000 to a typical 200 to 300 square foot tiny house build. That investment pushes your wall STC ratings into the low to mid 40s. At STC 45, Loud conversation on the other side of your wall is audible but not intelligible. Most park noise is significantly reduced. A full high-performance acoustic build, the kind that uses mineral wool, MLV on all surfaces, resilient isolation clips, and hat channel, double-layer 5/8-inch drywall with green glue compound, laminated double-pane windows, solid-core exterior doors with compression weather stripping, and acoustic caulk on every penetration. Adds approximately $5,000 to $8,000 to the build cost compared to a basic spec. In return, you can expect wall STC ratings in the low to mid-50s. At that level, you are approaching the same noise isolation standard that the International Building Code requires between units in apartment buildings. For a tiny house that might cost $60,000 to $90,000 to build fully, that acoustic upgrade represents about 6 to 13% of total build cost. For a house you plan to live in for 10 or 20 years, that math is straightforward. There is one important reality check on the weight side. A full acoustic build adds weight. MLV weighs 1 pound per square foot. If you cover 400 square feet of wall, floor, and ceiling with MLV, you're adding 400 pounds to the structure before drywall, insulation, and clips are factored in. Double drywall layers add even more than people expect. A dual layer of 5/8-inch drywall weighs roughly 4.4 pounds per square foot combined, which on a tiny house can quietly eat up 1,500 pounds or more of cargo capacity on its own. This weight must be accounted for in your trailer rating and your gross vehicle weight calculation. Work with a builder who understands both acoustics and THOW weight constraints, because those two goals are sometimes in tension and require deliberate engineering decisions. I promised you at the start of this video that there was one assembly mistake most tiny house builders still make. Here it is. They treat soundproofing as a finished step instead of a framing step. Most people who realize their tiny house is too loud try to fix it after the fact. They add acoustic foam panels to the walls. They hang heavy curtains. They put rugs on the floor. They buy a white noise machine. Here is the brutal truth. Acoustic foam panels, the kind you see in recording studios, are sound absorption products. They make the room sound better by reducing echo and reverberation inside the space. They do not block sound from entering or leaving the wall. They have essentially zero effect on the sound coming in from outside. White noise machines mask noise by adding competing sound. They do not eliminate noise. They are a coping mechanism, not a solution. The only way to build a genuinely quiet tiny house is to engineer the acoustic performance into the wall assembly during construction. Mass, damping, decoupling, and absorption happen inside the wall cavity between the studs before the drywall goes on. Once the walls are closed up, your acoustic performance is essentially locked in. If you're planning a tiny house build and noise matters to you, bring the acoustic conversation to your builder before the framing starts. Ask specifically about MLV, mineral wool insulation, resilient channel or RSIC clips, and double drywall with green glue. If the builder looks at you blankly or tells you foam panels on the walls will take care of it, find a different builder. If you are buying rather than building, the acoustic question is trickier because most prefab tiny house listings do not mention STC ratings. Here's what to ask. First, ask about the wall assembly. What insulation is in the exterior walls? If the answer is fiberglass bats or spray foam only, the acoustic performance will be basic. Ask whether MLV or mineral wool is used. Ask whether the drywall is screwed directly to studs or mounted on a resilient channel. Second, ask about window specs. Single pane or double pane? What is the glass type? Laminated glass is the upgrade you want for noise. Third, ask about pipe treatment. Is there any acoustic wrap on drain lines? Is the underside of the trailer belly treated for sound? Most prefab tiny house builders at the entry price point of $40,000 to $65,000 build to a basic acoustic spec because buyers rarely ask about it. At the premium tier, above $80,000, some builders are beginning to market acoustic performance as a differentiating feature. Ask for specifics, not marketing language. Steel frame, tiny houses, and container homes also deserve mention here. Light gauge steel framing actually transmits sound vibration more easily than wood, because metal behaves like a tuning fork and carries vibration efficiently through the structure. That sounds like a disadvantage, and on its own, it is. However, when a steel frame is properly isolated with rubber grommets, acoustic gaskets, and decoupling tape at every attachment point, it can match or even outperform a wood frame structure, because those isolators break the vibration path entirely before it ever reaches the interior skin. If you're looking at steel frame prefabs, ask specifically about vibration isolation at the frame-to-panel attachment points. Here is where this lands. A tiny house with a built-in sound barrier is not a fantasy. It is an engineering choice made during design and framing, using real materials that are available right now at real prices. MLV at $2 to $3 a square foot. Mineral wool insulation at $1.10 to $1.40 a square foot. Isolation clips at roughly $6 each, paired with $1 a foot hat channels. Green glued damping compound. Acoustic caulk. Double pane or laminated glass windows. Solid core doors with compression weather stripping. Layer those correctly during construction, and you can build a 200 to 300 square foot tiny house that holds its quiet better than most standard construction studio apartments. You can park next to traffic, share a lot with neighbors, sleep 6 feet from your refrigerator, and still get a good night of rest. That is what a real built-in sound barrier gives you. Not silence, because nothing built from wood and vinyl on a trailer will ever be completely silent, but genuine, livable quiet. The kind that makes tiny house life not just tolerable, but actually peaceful. And that is worth every dollar of the upgrade. If this kind of honest, technical breakdown is what you come here for, do me a favor and leave a comment below. Tell me what your biggest tiny house build concern is right now. I read every comment, and it helps me figure out what to cover next. If you want to go deeper on tiny house wall assemblies, check out the video linked right here where I break down insulation options from spray foam to mineral wool side by side on cost and performance. Until next time, I am your host here at Affordable Tiny Homes. Build smart, build quiet, and we will see you in the next one.